Hey everyone, it's Ben from GroundX AI. We help you build LLM apps with less hallucination and better performance in as little as a few minutes. With GroundX, you can achieve as high as 95% accuracy by combining our APIs with an LLM such as ChatGPT-4. If you haven't seen our introduction video and want some background on the company, the architecture of the system, or some of the challenges of using a vector database such as Pinecone with your content, I suggest you check it out. I go into the issues of using a vector database and vector search with a document such as a courtroom trial transcript, and I'm going to use this trial transcript in the demonstration that I'm going to do for you in this video. Before I show you how to process this 300-page PDF from a courtroom trial transcript into GroundX so that it can be searched and relevant snippets retrieved from the document, I'm going to show you how to create a preprocessor. As you may recall from the introduction video, a courtroom trial transcript has all kinds of issues that need to be addressed using a preprocessor in order to make the document intelligible to an LLM such as ChatGPT. On this single page 65 of the transcript alone, there is extraneous text in the margins of the document that provide metadata to a human reader, but really hinder the text extraction process. The court reporter also only identifies the speakers in the trial early on page 3 of the document. On subsequent pages, such as this one, they are referred to as Q and A. When you extract the text from this document, something like this footer, which looks like this, will extract into text that looks like this. The footer and the line numbers are intermixed with the sentence, turning it into something completely useless to an LLM. I'm going to show you how you can use GroundX APIs to turn this text from this into this. Like I said, we'll do this with what we call preprocessors, which are a GroundX concept. You can use preprocessors from our library or build your own using GroundScript. Now I'm going to open my code editor and create a JSON request object. I'm going to name my preprocessor something meaningful to me. I'm also going to give it a description so I remember what this preprocessor does. And then I'm going to write actual GroundScript, which is a proprietary language that we created to help speed up this process. And this GroundScript will transform the document into text that's perfectly formatted and chunked for search and use with LLMs. As you may recall, there's all kinds of extraneous text in the margins of this document. But the good thing about a document such as a trial transcript is that all of them are in the same basic format. So if I write a preprocessor that will crop out the margins of this document, I can remove the garbage from every page of this document and any other trial transcript that I want to ingest in the future. There's absolutely nothing useful in these margins to an LLM other than the page number, and those are already being captured as part of the GroundX ingestion process. So I'll use a simple GroundScript command to crop the document margins down and remove all the extraneous text. Next, I'm going to manually add some metadata about this document. There are commands that you can use in GroundX to automatically extract this kind of metadata, but for demonstration purposes, I'm going to explicitly define metadata so that I can show it to you in subsequent requests. This metadata is going to be included with every chunk of text that's retrieved when the text comes from this document during a search. Then I'm going to explicitly define important entities that are in the document. Again, you can use helper functions to do this, to automatically extract relevant entities from the document, but you can also explicitly define them just like I'm doing here. And that's it for this particular preprocessor. I'm going to switch to my terminal window and run a curl command to submit the request that I just wrote to the GroundX APIs. After I do that, I get back this ID, which is going to be important later in this demo. So I'm going to go ahead and copy it out and save it to a notepad. I'll use this ID when I upload a document later in this demo. And if I don't save it to a notepad, I can always query for it later, but for the purposes of this demo, it'll just be easier for me to copy and save it. Next, I'm going to create a document upload request in my code editor. And in order to do that, I'm going to include one or more document URLs in the request and the preprocessors that I want to use and apply to this document as it's being ingested. These are in addition to the default preprocessors that are applied with every content upload into GroundX. I'm going to paste the ID that I saved from earlier. And finally, I'm going to tell GroundX what the file types are. This is optional. If they aren't included, the platform will try and infer the file type as it's being processed, but you can also explicitly define it as I'm doing here. Now I'm going to switch back to my terminal window and submit a curl request to upload the document. I get another ID back in response to the API request for the document itself, and I'm going to save that as well so that I can query for the status of the document and retrieve metadata about the document when it's done processing. In order to do that, I do another curl request to the GroundX APIs, and I include the document ID in the request. The API returns information about the document because it's done being processed through the ingestion pipeline. As I scroll through the response, you can see the metadata that's been applied to the document. The information we explicitly said about the document, witnesses, etc., as well as classes that were automatically extracted by GroundX during ingestion. The other metadata we set is also included here using the key values we configured in the preprocessor. Like I said, this information will be included with each search and retrieval request. Let me show you what that looks like. First, we need to switch back over to our code editor and create a JSON request object for a search. In this request, we can optionally define preprocessors. We may want to do this if we've defined custom classes or if we've defined a custom model for entity extraction or any other number of reasons. We want to reuse the same kinds of preprocessors that were used to generate the data on the search queries themselves, and doing this will produce a better match during search. I'm going to paste in the ID for the preprocessor we created earlier. Then I'm going to add my query. I switch back to my terminal so that I can submit a curl request with the query I just wrote. The API returns relevant chunks based on my query, And you can see the metadata that was manually defined in the preprocessor, as well as metadata that was automatically applied to the chunk by GroundX during ingestion. This relevance score is for the result and can be used for things like hallucination prevention. And this particular section contains the processed chunk of text. You can use this chunk of text as well as the metadata to construct a better context for your LLM completion requests. This is how you're going to be able to get more accurate completions with less hallucination. It's the old garbage in, garbage out adage. Better search results with more context are going to produce better performance from your LLM completions. So that's it for this demo. Thanks for taking the time to learn more about GroundX today, and I hope to see you using the API soon.